general relativity, step by step. I'm trying to find a candidate for x on the left-hand side to give field equations with a right-hand side of a constant times the stress energy tensor. And a natural, so we don't know what x is, and we're trying to find a good candidate. But we've got the Ricci tensor here, and it makes sense to try and come up with a raised version. We'll call that gamma and sigma. So that's the gamma and that's the sigma. And we've got the Ricci tensor alpha beta here. So it's summed on the left over alpha and beta. And we've got a Ricci tensor, but with two upstairs indices to match the two upstairs indices here. And Einstein thought for a long time that alpha beta, see how I casually call it gamma and sigma here and alpha beta, it doesn't matter. I can call them circle and square. In fact, I'm going to. Equals k, t, circle and square. It's a bit difficult in terms of handwriting that. But anyway, we've got a Ricci tensor with two upstairs indices equals k, t, alpha, beta. This is guess number one. We'll see that it's guess number one. It was Einstein's guess, so it's not too shabby. And if Einstein thought it was right for a few years, there must be something to it. I'm not a historian of science by any means, but my understanding was that Einstein thought this was the correct form of the field equations for quite a few years. But it's not. And we know it's not because if I take alpha, beta, I take the covariant derivative with respect to beta, that will have to be equal to alpha, beta, semicolon, beta on this side, which equals 0. So what I want to do is to evaluate that. I want to evaluate this. And we better hope it turns out to be 0. Well, I don't know about hope. If it turns out to be 0, then this is a candidate for the left-hand side of the field equations. But as we'll see, it doesn't evaluate to 0. Okay, so what is this thing? R alpha beta equals what? Well, we start out with the... I'm not going to use alpha and beta. I'm going to use gamma and sigma. We contract with these indices here, G, blah, blah. I want you to see again how I'm writing in the skeleton of the equation that I want, and now I'm going to fill in the indices so that it's correct in terms of summation and positioning of these guys here. So we're summing over alpha. I've got gamma and sigma. What have I got left? I've got a beta and a nu. So I'm going to put a beta there and a nu there, and I'm going to sum that beta with that beta there, and that nu with that nu there. This gamma here is going to be that gamma there, and that sigma is going to be that sigma there. And I can also write it down in a slightly more convenient way of noting this. Well, we just write alpha, beta, mu, nu. So what have I done? I've taken, there's an upstairs index here which I want to take downstairs. So what that means, what does it mean? It means G beta gamma, G nu sigma, just those two terms copied there. And I'm using the fact that's got to be a G. And what have I got left? I've got an alpha. And I've got a mu here. 1, 2, 3, 4. And what have I got free? I have got on the right hand side gamma is free and sigma is free. So we've got this rather nice equation. I want to impress upon you again, I keep on saying this, but it's important. The actual symbols I use are unimportant. I've called it alpha and beta here because I'm so used to writing the stress energy tensor with an alpha and a beta. But I could write it down with anything. I could write it star and exclamation mark. I could write anything, any variable at all. Okay, so now I have to evaluate R gamma sigma semicolon. Well, what I'm actually going to do is take a covariant derivative with respect to a delta, and that equals R alpha, beta, mu, nu, just copying from here, G, beta, gamma, G, mu, sigma, G, alpha, mu. Oops, that's a beta. I'm so used to writing alpha, beta. Put it in brackets just so we know where we are, semicolon, delta. Well, that's a bit of a pain, because we are taking a covariant derivative with respect to a product of 4 things. However, I'm just going to note that G gamma, well, again, the variables can be anything, equals 0. The covariant derivative of the metric tensor is 0. Why? Because I can construct whatever frame I'm talking about and whatever coordinate systems I've got, I can construct a coordinate system in which the metric tensor is constant, and therefore it's got a 0 derivative. And if it's got a 0 derivative in one coordinate system, it's got a zero derivative in every coordinate system. By the comma goes to semicolon rule. So what that means is that these guys here commute past the differentiation. So I can say, just writing out the left-hand side again, semicolon delta equals G. I'm just going to copy these G's. I'm going to take them out of the bracket. Nu sigma G alpha mu times R alpha beta mu nu semicolon delta. Okay, equals what? Well, what we need to do is to choose. I'm going to stop, right, get rid of that equals there. I'm going to choose a local inertial frame, an elevator frame. There's an elevator and me trapped inside it, and I'm going to do some physics and I'm going to construct a coordinate system that's nice and easy. And of course this is constant, which is why I can take this out of my covariant differentiation. By the comma goes to semicolon. So I need to evaluate R alpha beta mu nu semicolon D. Maybe this is 0. It could well be 0. Lots of things cancel out in relativity, but, well, we'll just have to see. Excuse me. Well, no, I don't need a semicolon. I just need a comma there. So what that is di by di x delta of this coordinate free system here. Now, because I'm working in a local inertial frame, my Christoffel symbols come out to be 0, so I can replace this with my local inertial frame version. So I've got di by di x delta of, I think it's a half. Now what I've got to do is to copy from my notes, because no one can remember all of this stuff. Let's see if I can just copy this down. A half G alpha mu comma beta nu, just reading from my notes here, plus G, let me just write it down and I'll talk about it, beta nu comma, easy to make mistakes here, alpha mu minus G alpha nu comma beta mu. Is it minus or plus? It's minus. We've got 2 pluses, 2 minuses. G, what's left? We've got beta mu, comma, alpha mu. Yeah. And I'll take the half out as well, I guess. Half just being a constant. Observe that if I just look at this term here, beta mu semicolon alpha nu equals 0. But I'm not considering a covariant derivative, I'm considering an ordinary derivative which is not equal to 0. Okay, well, it's quite possible that things are going to cancel out. Let's have a look. But I'll stop here because this has already gone on too long, and I'll do it in the next screencast. Stop.